Hi guys, today's lesson we're working on Pythagoras' theorem. Okay, so let's start with the basics. So first up, Pythagoras. Who exactly is this Pythagoras guy? Well, he was a Greek mathematician who discovered a useful theorem on right angle triangles. Make sure it's always right angle triangles. And he discovered it in 495 BC. Next up, the next word I want you to know about is this word hypotenuse. So the hypotenuse of a right angle triangle is it's the longest side. It's also opposite the right angle. So if I look at this triangle down here, this is definitely the longest side of my right angle triangle. That's my hypotenuse, and it's also straight across from that right angle. So there's a couple of ways to figure out which side is the hypotenuse. Okay, so next up, what was Pythagoras' interesting or useful theorem? Well, it's this one right here. It's this one here, a squared plus b squared equals c squared. That's what the law states, where c is the hypotenuse and the a and the b are the shorter sides. So that's how you know what he means by a, b, and c. They're just sides relating to a triangle. So like up here, that could be your c, that's your longest side. This would be a and that would be b. You can swap around the a and the b, by the way, because a and b, it doesn't matter which shorter side they are, they just got to be the shorter sides. The next one I want you to remember, this one is easily forgotten about, a Pythagorean triad. So that's pretty much just three whole numbers. They have to be whole numbers. They can't be decimals or fractions or anything, which can be used to make a right angle triangle, i.e. they satisfy Pythagoras' theorem, because that was all about right angle triangles. So for example, 3, 4, and 5 is a Pythagorean triad. And the reason for that is if I write down the formula, or the theorem, and I put in 3, 4, and 5, that comes out as 9 plus 16 equals 25. And that's like a true equation. So because it's true, it satisfies Pythagoras' theorem, and therefore it is a Pythagorean triad. Also, if I actually make the triangle using these three numbers, in fact, that does make a perfect right angle triangle. So that is, so if we let that be 3 and that be 4, that should definitely be 5. Don't worry about how many like squares I've got in there. Okay, so let's move on. So some rules to remember. Why are we learning this? Well, the main reason is because we can use this theorem to find an unknown side length. Really important. If I give you the other two sides. So if I give you two sides of a right angle triangle, just like I do here, I've given you this side and this side. This is enough information for you to be able to tell me what the third side is using Pythagoras' theorem. Now I want this to 3 decimal places. Okay, so let's give it a try. So the first thing I want you to do with your triangle is to label the sides A, B, and C. So C has to be your longest side, and the A and B have to be the other two sides. Okay, so C is my longest there. A and B are the two shorter ones. Okay, and now once we've labelled it, I want you to then write the theorem out. A squared plus B squared equals C squared. Now my A is 5, my B is 12, and my C is X. So they're each going to change to those values. So C is X, B is 12, and A is 5. And moving on, now we think to ourselves, let's have a look at what we've now written. Well, 5 squared is 25. 12 squared is 144, and x squared, well, you can't change that, it just stays x squared. And now we simplify further. Okay, so 25 plus 144, that makes you 169, and your x squared comes down. And now we think to ourselves, we need to get x by itself. We're trying to figure out what x is, so we need to get rid of this, this squared right here. What's the opposite of squared? Well, we've got to think opposite of squared is the square root. So what we do to one side, we do to the other side. Just square root both sides. The square root and the square, they literally cancel each other out. So I'm going to scribble all this stuff out, leaving with just x. And the square root of 169, well, that's just 13. We can use a calculator for that if you're having trouble with that one. So if x is 13, we figured out this unknown length. Sorry, so x is 13. So this is actually 13 centimeters. So I probably should have written that in. I'll do that now. So it's 13 centimeters. Okay, moving on. Determine if the following triangle, so this triangle here, determine if it has a right angle. So here I look at my angles and I think, well, they don't give us any right angles, but we can determine whether it actually secretly does. I.e., are these three numbers here, 6, 8, and 10, is that a Pythagorean triad? Does that satisfy Pythagoras' theorem? So what you do is you start with the formula, a squared plus b squared equals c squared, and now we substitute. So remember, our c is our longest number, our longest side, 10, and the b and the a go to our other shorter sides, our 8 and our 6. So we shove those in, and we have to think to ourselves, is this equation, is this true or false? Is this a true equation or a false equation? So let's find out. Well, we've got all our, sorry, I stuffed that up. We've got all our numbers being squared. So, okay, so we've got all our numbers being squared. So 6 squared, well, that makes 36. 8 squared equals 64. And 10 squared equals 100. So that's the first thing I want you to do. And once you do that, I want you to look at this left-hand side of our equal sign and simplify that as much as possible. 36 plus 64 equals 100. So therefore you get 100 equals 100. Now that is definitely true. 100 definitely does equal 100. That's a true equation. And so when it is true, so yes, it's true, we are given a right angle in our triangle has a right angle. So yes, the triangle does have a right angle. If we got something like 100 equals 90 or something, that would be a false equation, and you would say that no, there is no right angle in this triangle. But this one definitely does. You can see here that opposite the longest side, that would be our right angle right there. So hopefully these few questions help you out a bit with the work today. Good